Should be good. Test. Okay. Good to go? Okay, so hi everybody. So my name is Harizo. I'm a data scientist working at Dataiku in the Paris office, so visiting Amsterdam for the day. And tonight I'm going to talk to you about testing and monitoring for production-ready models. And this hashtag here means operationalization, so I'm going to say this once and only once tonight. Okay, so very briefly about the company. So as you may have guessed, it's using a Japanese roots. We don't have any Japanese people among the co-founders, so figures. So yeah, basically we are a company that we provide an end-to-end platform for data science. We are a bit more than 5 years old, and we have hired, I think, our 160th employee not so long ago. So this slide gives you a static glimpse of the software. Long Hao already showed you a bit more interesting things. If you want to try it out, don't hesitate. It's just a matter of 4 lines in your terminal to get it up and running. And you also have pre-built images on the Azure and AWS marketplaces. Last but not least, we are hiring. So if you're interested and if you want to learn more about what we do at Dataiku, don't hesitate to talk to me or to my colleague Hilke and also to Sofiane. We will be happy to answer any question you have about the company itself. So, very quick show of hands. Who in the room is a data scientist? Okay, who is doing more engineering ops things? Well, not that many. Okay, well, my point. Because the thing is, when you say I'm going to deploy something into production, for software engineering, as you see in this picture, it's pretty clear. There are already a lot of things that are in place, versioning, agile methods, continuous integration, continuous deployments, so on. But for the data science, it's a bit more complex because there are, let's say, different steps that you have to take. And you also have this dependency to data. And you will see that this might be problematic because in the world of software engineering, when you're doing tests and you're doing deployment, you are rather working on purely deterministic things. But as you've already experienced, I guess, in data science, well, there is this non-deterministic part regarding how your model behaves and how is your actual data. So deploying in data science is definitely not the same as in software engineering, but we still need some of the elements that are present when you're doing CI/CD and stuff like that in software engineering. Especially if you want to iterate faster, the idea is to say that unless you want to, well, you don't want to wait too long for releases, you want to iterate faster with small iterations, and deploy quickly, because when you're in production, well, there is the business impact. You also want to test on your data and on your models at multiple levels. But, as I said, the non-deterministic problems, dependency on data, and you also have the case where you're relying on both code and, let's say, visual GUI tools and like putting everything together might be a bit complicated if you want to have a clean deployment pipeline. So that makes things a bit complicated. But fortunately, a bunch of very smart people at Google worked on the question and issued a paper not so long ago that is called the ML test score. So who's familiar with the Joel test? So the Joel test is basically an old, well, it's not that old. It's basically a list of boxes that you have to tick if you want to work in, let's say, in an efficient software company as a developer. And here, basically, the ML test score is the equivalent. What you do is, what the Google guys did was list 28 tests for deploying machine learning-based systems. And every time you validate one of those tests, then you win some points. And then they deployed that internally and evaluated for each team working on machine learning-based tools how efficient in, let's say, deployment they were. And those tests focus on those 4 areas, so features and data, model development, infrastructure, and monitoring. So I will definitely not have the time to go over the 28 different points tonight, but I will focus on the last 2, on some of the last 2, namely infra and monitoring. And as an example, as a running example, I will take some data from an old Kaggle challenge that is the Rossmann challenge. So if you're interested, the data is available online, of course. And the goal of this challenge was actually pretty simple. The idea was to predict daily sales in German stores. Well, the features were already pre-built, so I did not do much of feature engineering. The interesting part is that this is data that is divided into monthly pieces, meaning that you can easily simulate an environment where you get data as time comes and goes. And yeah, it's a regression problem, basically. Well, it's a forecasting problem that was formulated as a regression problem. So the first test that we'll be looking at is what is dubbed as test infra 4 in the paper. So this one says the model quality should be validated before attempting to serve it. And by serving, they mean deploying to production so that it's accessible via a, let's say, direct query system like a REST API. So when you're doing model quality validation, you also touch the subject of a periodical retraining of your machine learning model. There was a question about that during the first talk. What happens if I have data coming in periodically or just arriving as time passes? How do I retrain my model? How do I re-execute the whole pipeline? And basically, when I get new data, how do I check that after retraining the model is better than the previous one, and then I'm going to deploy it? Here, you will see that the framework will be pretty simple. We will, every time that the data comes in, we will re-execute the pipeline, and at the end, we will do a split between the training test and the test set. And basically, we will use the test set as a common ground between the 2 different, let's say, generations of model, because what you want to do if you want to update a machine learning model is, of course, to use the same test set to compare their performances. So this is sometimes called the champion-challenger problem. There are many implementations of this kind of problem, and this is a very simple one. Imagine that you have new data coming in, you apply data preparation, feature engineering, and you apply your split. And then you verify if the champion which is the actual model in place that is currently deployed, is the champion still good, still doing good with our new test set? Is the performance still relevant? If yes, then it stays. If not, then we will launch the retraining sequence and train a batch of new challengers on this new training data. And then you take the best challenger and you verify that this best challenger is actually better than the champion. If so, then, well, the best challenger becomes the new champion. And if not, it means that there was a consequent drift in your data. That may be one of the explanations. So that's where you switch back to, let's say, manual mode. And you say, OK, I have something a bit weird going on. And that's the part where you need to investigate further your data set and your feature engineering, because maybe with the new data coming in, some features are less relevant, or there are some quality issues with the new data. So we're going to demo this live. So there will be a part of randomness in it, but that's the fun part, let's say. Okay, so here I'm on my DSS instance. I'm going to work on this project, which is called the Model Monitoring Project. So, as you see here, I have the flow. So the flow is the visual representation of my data science project. And basically here, what I have is the raw data coming in every month in the form of CSV files somewhere in a folder. And then every time I have new data coming in, well, I will apply some data cleaning here. I will join this with the data regarding the stores, and then I will do my train test split, and then train the model. So nothing fancy here, and that's the good thing with Kaggle challenges, because you already have sometimes pretty neat features. And now, imagine that I have this model in place, which is the champion. So my champion is this one. Actually, it's the, let's make it active like this, confirm, and I will delete this one, which is an old one. So my champion is a stochastic gradient descent regression model. And what we will do is to say, okay, we will simulate the arrival of new data, rerun the preparation pipeline, and check whether or not the new data triggered, let's say, a new model. So to do that, I will very simply go inside my folder, and I will add the files. So I'm going to go here. So I'm doing this manually, but imagine that in real life, you may have some automated process that puts those CSVs inside that, that folder. So I have up to June. Let's put July and August in addition. Okay. So here, now I have my new data in place. Now, the next steps are running the pipeline, retraining the model, checking if, well, running the pipeline, checking if the new test set still validates the champion, and if not, retrain the model. And you see on the top right that something already started. This is because within DSS, within Dataiku, you have a built-in scheduling system that basically allows you to automate tasks. And here I have something called a scenario that I defined that will basically, every time that I add new data to this folder, automatically launch the pipeline, meaning computing this, looking at the performance of the existing champion on the new test set. If not, well, if it's not relevant, then retrain new challengers, pick the best one, and then deploy it. Everything is automated on this scenario. And basically, this scenario is a sequence of steps. I can show you how it looks like. So here you see that I defined a trigger saying that every time something new happens in my folder, then launch the scenario, and I have this series of steps where I do my data preparation. I am looking at the performance of the model on the test set. And here I have this a bit custom step where I'm using Python code to manage all of the retraining and deployment of the best challenger. So it told me that I'm done. So now let's take a look here. And you see here that actually I have this new model that performs better than the previous one and that already replaced the other one. So here I have this champion challenger scenario that was fully automated to replace and deprecated the previous one that is the champion. So that's, let's say, one way of automating the retraining and verifying the quality of your model before actually deploying it. Here, the quality of the model is its performance regarding the new test set. But sometimes it can be a bit more difficult to define. Because you may not just look at purely mathematical metrics. You may also want to look at business metrics, because every time you have something running in production, you also have, well, the business people will tell you that your model is not working, not because the root mean square error is a bit weird, but because the customers are not buying, because something more way different than something like purely mathematical. And there are some things to be very careful about when you're running champion-challenger scenarios, especially regarding the test set and the feature engineering pipeline, because it doesn't make sense if you compare two models that were not, let's say, were not generated using the exact same data preparation pipeline. You may also have the problem where your data arrives not that often, so you may want to review, let's say, the conditions on the retraining of your models. So that was test number 1. Let's take a look at another one, which is Infra 6. Models are tested via a Canary process before they enter production serving environment. Who's familiar with the concept of a Canary process or a Canary deployment? So basically, a Canary deployment is it's something that you have, again, in the software industry. Imagine that you're a company and you issue the new version of the software, for example, or a new website, let's say. What you may want to do, let's say, to test the waters, is to only affect a given percentage of your live traffic or of your users to the new version, and keep the old version to the majority. If everything goes well with this small fraction, then you deploy the new version to everybody, or otherwise you roll back. And that's basically achieved well, it's perfectly applicable in data science if you replace the software by a machine learning model, for example. So the idea is to say that you have here the version 1 of your, let's say, your machine learning model. You've trained version number 2, but you don't want to deploy it right away. What you want to do is only, actually here, there's a switch. You don't want to do this. Here it should be 90% and here 10%. But basically you keep 90% on V1 and you only redirect 10% on V2. And if everything goes well with V2, then all of the traffic actually goes to V2. So this allows for fast rollback. If you see that your model has a problem, then you know that it only affected 10% of the traffic, and it's very easy to go back to V1. But the rollout becomes a bit longer, which means that if your business people say, okay, this is critical, we need this new version right away, they may be pushing you a bit, because the Canary process may take some time for full validation. And the concept of validation itself can also be dubious, because you have to define it, and it will be specific to your model and also to your business. So we're going to see how this works in the context of the API node that Longhao presented in his talk earlier. So just before going back to the demo, just to explain you over a higher level how the services as API work in Dataiku. Basically, every time you retrain a model, you have the possibility to deploy a new version of a service, which means that you will update a service every time you retrain a model and you want to deploy it. And you also have the possibility to copy deployments from your dev environment to your prod environment seamlessly. This may be a bit obscure, but you will see that it's not that complicated when we move on to the demo, actually. Okay, so now I'm back here. I'm super happy that I have my new model validated here, and now I want to deploy it as an API. So what I'm going to do for that is I already have here in the API deployer interface, I already have V1 up and running, and let's say I want to deploy V2 of my new model. So to do that, and I'm going to deploy this using let's say a Canary-like deployment. And to do that, the first step will be to update the dev deployment to V2. So to do that, it's just a matter of selecting the service, Rossmann. And here the service is associated to a model. So a saved model is this green diamond that you saw in your flow. So here I already have this one, and I'm going to say, okay, I'm going to push it to the deployer, and it already knows that there is a V1 deployed, so it will suggest me, okay, let's move to V2. Now I click on OK. And then back to the deployer interface, I will see here on the left that I have V2 ready to be deployed. And now let's deploy V2. So I'm going to click here on deploy, and I'm going to update a deployment. I'm going to update this deployment here. I'm going to replace V1 by V2. You see here that the service is deployed on two deployments, this one and this one. I'm going to start by this one. And then I'm going to click on update. I'm going to replace the current version with V2. And then it's just a matter of clicking on update, selecting the default type of update, and then I'm all set. Now if I go back here to the deployment part, I see that V2 is up and running. And if I want to test if, well, V2 is actually up and running because I'm in my dev environment, I'm going to say, okay, let's test it against a sample query. So here I have this pre-generated code that I'm just going to take and copy-paste into my terminal. Yeah, I think I'm good. And if I just do this, you see here at the bottom that I have the JSON response with the prediction and a bunch of other metadata. So we're good. I have this prediction for the daily sales here. And I also have some timings, some other things, and especially you have here this tag, which is service generation, which is, well, the version of the model that was deployed. So everything is well in dev, and now let's move to prod. But remember, I want to deploy it Canary style, meaning that I don't want everything going to V2. I want, let's say, 10% going to V2 and 90% still going to V1. And to do that, I can, let's say, I can specify additional options when I deploy. So now I'm going to update the prod deployment. But this time I'm not going to deploy one generation. I'm going to deploy multiple generations. And here, to do that, I only have to edit this small JSON file saying that for V2, I'm going to affect the traffic to V2 with a probability of 0.9 per se. And let's keep V1 somewhere. Up, V1. And let's give it a probability of 0.1. 0.1. And my JSON is valid, yay. I click on save here, and I'm clicking on update, like this. And now, if I go back to the deployment, you see that in production, I have both V1 and V2 up and running. If I want to verify that, I can, as earlier, get the sample code, like this. And what I'm going to do is put that inside a file. Maybe mute this. Make it executable. And now what we're going to do is simulate a constant traffic on this endpoint to verify whether or not the, let's say, the routing is correct. So to do that, remember that it's just a matter of executing the code. And I'm going to only keep the prediction and the version that is here. So to do that, I'm going to say query. And then I'm going to pipe the output using this tool. So if you don't know JQ, it's a very handful command line tool that will allow you to, let's say, parse JSON very efficiently. It's very, you try it once and you can never come back. And so what we're going to do is not to keep everything, but we're going to only keep one JSON with the result of the prediction and the version of the service. So we will create a version key, and that is inside API context dot service generation. Like this. I only have the prediction and the version. And now, let's have even more fun, and let's put this into an infinite loop. While true, do this. No, I'm going to put some sleep so that we can see what actually is going on, and then done. Okay, so you see here that we have traffic going to both V2 and V1. I think I made the same mistake as earlier. Roll back. But actually, this is going to be very interesting. What happens if I do the changes without stopping the queries? What do you think will happen? Let's try it. Let's try it. So it's just a matter of going back to the settings here, correcting my mistake, going here, click on update, update it successfully. And now if I go back here, there was no traffic interruption because the API nodes support hot swaps of models. So you don't get, let's say, you don't get any downtime. And that's my point. So here we have, let's say, well, 90% going to V1 and 10% going to V2. And yeah, the final step, as you would have guessed it, is to switch to single generation. So I'm not going to stop it. I'm going to keep it running and then switch back to single generation. So that's the last step. This is where you validate your Canary and you say, okay, V2 is okay to go to production. So it's just a matter of saving, updating, and now I only have V2. Okay, so the Canary deployments, those are one example of deployment strategies. There are many others. You may be familiar with something called A/B testing, which is, let's say, a natural follow-up of this kind of deployment. So A/B testing is a bit peculiar because you don't want to do your split in a random fashion. Sometimes you have some rules to do the split between the population that you want to control, and I don't remember the exact terminology, but there are some criterions. The thing is, with the API nodes, here we have those endpoints that are machine learning models. But Longhao also said that you have more generic endpoints, like very simple Python function, very simple R functions, and you can chain them all together in a streaming fashion, which means that you can start hitting let's say an R function or a Python function endpoint that will define how to split between different endpoints, and then apply exactly what we did earlier here. Obviously, this can be automated. I did it in a fully manual way, but for example, you might say, I want to create an automation task that says, I'm going to deploy 10% on V2, 90% on V1, and after 7 days, if nothing burns, then I will move to V2 entirely. Of course, that can also be automated. And from a more, let's say, infrastructure perspective, you also have different ways of doing the splitting here. We did that at the service level. But if you're expecting high traffic on your endpoints, you may rather go to a split at the node level, meaning that the traffic itself will be routed to different API nodes depending on the version. And this will be managed by a load balancer. Okay, so I think that's the last one. So last test. Monitor 6. Model has not experienced a dramatic or slow leak regression in training speed, serving latency, throughput, resource usage, etc., etc. In one word, monitoring. Your model is up and running, and you want to know what's going on, if everything is going well. Basically, you will take a look at a list of different metrics. So obviously, for let's say your saved models, the one that we saw earlier after the champion challenger part, you may want to take a look at their performance, and especially if you have a drift in terms of performance in the long run. And this is something that you can very easily check, because every item here in the flow has a bunch of metadata. And namely, here, for the machine learning parts, we have, for every time you deploy a new version, you have a list of metrics here. So I'm working, as you may have guessed, on a regression problem. So you see the usual regression metrics. But you can also very well define your own custom metric by code. And this is, per se, the history of this deployed model across the different versions. And this you want to keep somewhere, because if you notice that there is a small drift over time that is slowly increasing, this is something that you may want to be careful about. You also may want to check the deployed model, so the endpoint, in terms of metrics. So for that, if you go to the deployer interface, you see here that you have those small graphs that basically look at the queries per second that are hitting the endpoint. So if you know which kind of traffic to expect, then it's a good indicator. You also have the possibility to take a look at the timings. You remember that in the JSON response that we got, there were the timings for each scoring point. So yeah, you can fetch those metrics on the fly, or you can also log them somewhere and use them for offline analysis. And especially if you're in the case where you have real-time feedback, meaning that you make a prediction about a data point and you get the actual value that should have been predicted not so long after that. That happens a lot in areas like online advertisements, where you want basically to check whether or not someone clicked somewhere. The feedback is pretty much instantaneous. If you have real-time feedback, you may also check for the latency of the arrival of your actual target value, because sometimes that can be tricky, especially if it's not regular, because you may assume that there is a problem and the target did not arrive, whereas everything is okay, it's just that there is some latency or less users, for example, who are hitting the endpoint. And yeah, for this demo is going to be a bit more static, because I already showed you those metrics here and the machine learning metrics that we have for the saved models. Here, the previous one here, those are timestamps at the millisecond, unique sepal. Yeah, because basically this is a multivariate time series. Well, every time you deploy a model and the performance for that deployment. Okay, so I'm reaching the end of the talk. So a few points regarding deployments. So testing and monitoring deployments for machine learning is not something that is easy. It's an investment, and but if it's worth it, then you should definitely do it, especially if you know that the models that you are deploying in production and that are hit by users or third-party application in real time have an impact on your business, then all of this testing and monitoring should be very important to you. You take the example of a bank. They're doing fraud detection on a real-time basis over credit card transactions. If you see that there is a feature that is weird, or if you know that improving the model a bit may reduce the percentage of fraudulent transaction by a given %, then you have to be sure that it works before deploying it. It is close to impossible to tick all of the 28 boxes of the ML test. If you read the paper, you will see that even within Google, they did not manage to do that, because the paper is not that generic. It only works for supervised problems, and some of the points are heavily biased towards, let's say, online training-like models, where they get like very, very fast feedback. In reality, you may not have this, let's say, this feedback loop put in place that fast, because you may have to wait before getting the actual value of the target that you're predicting. So other important tests that we did not mention, but which are pretty obvious, the quality of the features. Make sure that your features are relevant and are still easy to implement. Make sure that you tune your hyperparameters. Make sure that you can clearly version and roll back your models. Something also interesting, make sure that you test every model that you deploy against a very dumb baseline. Because, well, that's what people do in Kaggle sometimes. But it also it's also useful in production. That's a very simple test to say to see whether or not there is something really wrong with your model. If your model does worse, if your fancy neural network does worse than your dumb linear regression, you know that something weird is going on. And as I said earlier, you have other types of deployment strategies. So you have rolling updates. Remember that Canary was a two-step transition. Rolling update is just to say that you're slowly shifting traffic from one version to another. You have blue-green deployments. That means that you you duplicate basically the infrastructure for version 2, and you switch everything to version 2 once everything is up and running for version 2. And we mentioned A/B testing. Again, everybody, let's say, everybody will have his own deployment strategy because those are very specific to your business, to your models, to your infrastructure, and so on. So that's it. Thanks for your attention, and if you have questions, fire away. Thanks.
I work in environments with a lot of time series data, and now I see the models that we saw tonight. Okay, maybe they are dummy models, but what is kind of the feeling for volumes of data on the platform that you showed?
So in terms of feature engineering, basically, the Dataiku DSS acts more like an orchestrator, meaning that it's not meant to be, let's say, a computation platform, because here in this example, you have data that are stored into databases, and those two operations, they're not executed by DSS. They're executed by the database itself, which means that the DSS only says to the database, join those two tables, and that's it. And that's basically how it works. The heavy lifting is not done by DSS itself, but by the infrastructure. If you want to distribute the training of your machine learning models, you can leverage Spark, meaning that you will have the exact same interface that was shown during the first talk. But when you click on the train button, the work will be done by the Spark cluster. So in terms of scaling, in terms of data volume, that will be done mostly by the infrastructure where DSS is plugged, and not by the DSS design itself.
Thank you.
Following questions, yeah?
My question is also not directly about operations, but more in general, because at the end you said about versioning.
Yep.
And I saw on your website that you also do, for instance, Git and versioning, and you also saw like everything that has changed is being kept. But then I was kind of confused because then it says that Git that you can't merge stuff and you can't do branches. So I was curious, how do you have multiple people work on different versions?
So if you want to branch, you have the graph here. So basically what people do is they create, let's say, visual branches. You can, for example, spawn another model here that you may want to use in parallel to this one. The reason we don't do actual Git branching is because if you start branching the code, you also need to branch the input and output data. And this is something that causes conflicts. So that's why you have this graph structure. Basically, if you want to branch, you will just create, for example, a new version of one part of the pipeline here, so that there is no conflict, and you actually see the other branch.
Thank you.
All right. That's it? No more questions? All right. Thank you all very much for coming, and one big applause for
Thanks.
Yeah, thank you all very much for coming. Maybe
Hours over, is it?
Yeah, of course.
Next half hour, something like that.